Hi everyone, today I'm going to be teaching you how to use fraction towers to teach equivalent fractions and fractions in the simplest forms. So first, let's take a look at all of our towers here. We have red, which is equal to 1 whole. We have pink for the halves. The thirds are orange, the yellows are fourths, the greens are fifths, the sixths are light blue, the eighths are dark blue, the tens are purples, and the 12s are black. So, what's something we notice having these right beside each other? And right off the bat, I noticed that all of these are the same height. And because we already know that red is 1 and this is the size of 1, we can infer that all of these are equal to 1 as well. So we know that these are all equivalent fractions. So with this knowledge in mind, we know that whenever two fraction towers are the same height, they are indeed equivalent fractions. Let's use a few examples to showcase this. So, question number 1 says, are 3/6 and 1/2 equivalent fractions? So first thing I'm going to do is grab 3/6. So we have 1, 2, 3. Three six and 1/2. So now I'll grab 1/2 and I'll place these beside each other, and they look the same height to me. So yes, they are equivalent fractions. So I'm going to put a check mark right here. Okay, our next question says, are 1/3 and 1/6 equivalent fractions? So again, the first thing I'm going to do is grab 1/3, put it aside, grab 1/6, which is over here, and oh, they're not the same size, so because of that, they are not equivalent fractions. So no. Next. Are 1/2 and 1/3 equivalent fractions? Again, I'm going to grab the 1/2 right here, and I'm going to grab 1/3 and measure them next to each other. And no, they're not equivalent fractions, so I can go on and make an X by this one as well. So if we were to look back at question number 2, are 1/3 and 1/6 equivalent fractions? I'm just going to bring back the cubes again. So 1/3 and 1/6. They were not equivalent fractions, but what can I do to make this an equivalent fraction? Well, I can add another 1/6 block. And properly showcase that 2/6 and 1/3 are equivalent fractions. You can also model how to simplify fractions using these towers, like so. So let's say I have 1, 2, 3, 4, 5, 6 12s. So I'm gonna write this right here for reference. Here we have 6 12s, but we want to make this into a smaller number. We don't want the 6 and we don't want our 12. So how can we divide in order to make this a simpler fraction? Okay, well, if we're looking at our fraction towers right here, let's see. We know that if we were to divide both portions, the numerator and the denominator, by 2, that will get a simpler number. And that should be equal to 6 12s. So if we take a look, we'll see that 3/6 would be equivalent to 6 12s. Okay, but maybe we can make this a smaller fraction. How can we do that? So using that same logic again, let's take a look at our fraction models again. So we have 3/6 up here, and we know that if we divide both the numerator and the denominator by 3, we'll get 1/2. So therefore, 6 12 can be simplified into 3/6, but that can be simplified into 1/2. So therefore, the simplest form of 6 12s is 1/2. And we did this by looking at our fraction models.